Hi again, Year 12. So in a second I'm going to show you how to do some questions like the ones in exercise 11C, but first I wanted to have a look at why we differentiate to go from displacement to velocity, for instance. So we already know on a displacement time graph, which could look something like this. I don't know why it's sideways. If I wanted to find the velocity on one of these, I would take the gradient, or ds by dt. Similarly, if I had a velocity time graph, let's say it looks similar, then to get the acceleration, I would again find the gradient, or dv dt. So the questions we're going to look at in exercise 11C ask us to find the maximum or the minimum values of displacement or velocity. So for instance, the question could say S, our displacement of say a particle is 0.6t plus 0.4 t squared minus 0.2 t cubed. And we're given a constraint here. T is between 0 and 3 seconds. So part A, why the constraint? Why are we told 0 has to be between 0 and 3 seconds? So the way we answer that, I would just substitute these two values in. So when t equals 0, s equals, if I put that into my calculator, I get 0. And when t equals 3, we also get s equals 0. And if you try values that are greater than 3, you'll find s is negative. So we must be in a situation where we're not allowed to have negative values of our displacement. So I would just say can't have negative displacement or something along those lines. Then part B, we are asked to find the maximum value of the displacement. I'm sorry about my terrible handwriting. So I'll write it again down here so I can see it better. S equals 0.6t plus 0.4t squared minus 0.2 t cubed. So the maximum value of the displacement will be when ds by dt has to be equal to 0. So we're looking for when the velocity is 0, and that's because we learned during the pure chapters that when we find a maximum or minimum point, the way we're going to do that is find when the gradient function is 0. So hopefully, if we had displacement against time, we'd see something like this, and this point up here, where the velocity is 0, that's what we're looking for. That's our maximum. So our gradient, our velocity, is going to be 0.6 plus 0.8t minus 0.6 t squared. And we're looking to find the point where 0.6 plus 0.8t minus 0.6 t squared equals 0. So I'm just going to pop those values into my calculator, or you could try and solve it in a different way, I suppose. But if you do that, you should get t can be 1.87 seconds or negative 0.54 seconds. And because we've already been told in the question t has to be between 0 or 3, we're going to reject this value because t has to be between 0 or 3. Then we're not quite done yet. We need to put this value of t, substitute it back into our displacement equation. So s equals 0.6 lots of 1.87 plus 0.4 lots of 1.87 squared minus 0.2 lots of 1.87 cubed. So 0.6 times 1.87. If we do that, we should end up with value of the displacement around 1.21 meters at its maximum. So after that point, after 1.87 seconds, the displacement starts to decrease again.